Hi there, in this video I'm going to do a past exam paper question on integration. So let's take a look at the question. Question number 3, part A, find the integral of x cos 2x with respect to x. So let's see how this question is going to be done. Let's get back to the paper and pen. So we need to integrate x cos 2x with respect to x, and the method here is by parts. So let's integrate by parts. So by parts, let's apply by parts. Here's the formula. The by parts formula goes like this: the integral of u dv over dx with respect to x, that is uv minus the integration of v du over dx with respect to x. Now when applying by parts, you need to choose u and dv over dx. So we need to select u and dv over dx so that v du over dx is easy to integrate. Now I usually take u to be the x term, so I'm going to take u to be x, which means that my dv over dx is the remaining term. Dv over dx here is cos 2x. So let's continue with the side calculation. We need du over dx and we also need v. Du over dx, so when I differentiate x, I get 1. V on the other hand is the integral of cos 2x with respect to x. And when you integrate cos, it's plus sign, so it's plus sine 2x divided by 2. So that is what you should have for v. Now let's substitute this data into the by parts formula, giving us the integral of u, which is x, dv over dx, which is cos 2x. So the left hand side corresponds to the question. That is equal to u is x, multiplied by v being sine 2x all over 2, minus the integral, so minus the integral of v, which is sine 2x all divided by 2, multiplied by du over dx, that being 1. Now what I would recommend is multiply the brackets before you actually integrate that term. So if I get rid of the brackets, we're going to have x sine 2x all over 2 minus, and the integration of sine 2x over 2 times 1 is sine 2x over 2. So let's continue one more step. So we'll have x sine 2x all over 2 minus, now when we integrate sine, it's minus cos, so bear that in mind. The two minuses, so minus with this minus is a plus, so we're going to have a plus cos 2x divided by, now I'm going to keep this 2 here, but when you integrate sine 2x rather, integration of sine 2x will be cos 2x divided by 2. Okay, so be really careful when you do this integral, plus a c for completeness, as we don't have limits. So if we simplify, we're going to end up with x sine 2x all over 2 plus the cos 2x divided by 2 times 2 being 4 plus the c at the end. So this should be the solution for the integral of x cos 2x, and we did that integral using by parts. Now if you're unfamiliar with the by parts method, I did do a video on integration by parts and I'll provide a link to that video in the description below. However, let's go back to the screenshot as we have another part to do. In part B is we need to use the identity cos 2x is equal to 2 cos squared x minus 1, and we need to deduce the integral of x cos squared x with respect to x. So let's think about how to do this. Let's get back to the paper and pen. So this is the identity that we need to use to find the integral of x cos squared x with respect to x. Now, if I rearrange this for cos squared, so let me switch sides. So 2 cos squared x minus 1 is cos 2x. And as I said, if I rearrange for cos squared x, first taking the minus 1 to the right will give me 2 cos squared x, and that being cos 2x plus 1. And if I divide both sides by 2, I'm going to have cos squared x, and that is half cos 2x plus half. Now, if we go back to the screenshot, now we need to deduce the integral of x cos squared x with respect to x. So back to the paper and pen, I have an expression for cos squared x, so I need that x in front. So what I'm going to do now is, if I multiply throughout by x, multiplying throughout by x will give me x times cos squared x is x cos squared x. That is equal to x times a half cos 2x is x over 2 cos 2x plus, and x times half is x over 2, or half x. Now, in order to work out the integral, which is what's required in the question, I can integrate every term, the left hand side as well as the terms on the right. So if I integrate both sides, I'll end up with the integral of x cos squared x with respect to x. That is equal to the integral of x over 2 cos 2x with respect to x. So I'm going to write it as two separate integrals, plus the integral of x over 2 with respect to x. Now, in addition to that, let me take out a common factor of half from the first integral. So if I take out a common factor of half out of the integral, I'm left with x cos 2x within this first integral, plus, and I'll do the same for the second integral. If I take out a common factor of half, I'm left with the integral of x with respect to x. Now, let's pause for a moment and think about this. Now, this integral here, so have an observation of that integral. That integral there, we have the solution to that integral in the first part of the problem. So when we integrated x cos 2x, and when we applied the method of by parts, here was the solution. So what I'm going to do is I'm going to incorporate that solution to help me solve this question over here. So let me replace this integral by its solution, which is this. And in addition to that, the integration of x, nice and easy. When you integrate x on its own, it's x squared over 2. So let's put this together. So we have half. Let me keep that half outside. Let's use a bracket just to be safe. When we integrated x cos 2x with respect to x, here is the solution, x sine 2x over 2 plus cos 2x over 4. So let's copy that down. So x sine 2x over 2 plus cos 2x divided by 4. So that is the solution which I've copied down from here, from the previous part, part A, plus, so a plus half, so plus half from here. When I integrate x, that being x squared over 2. Let's add the plus c here. So we're nearly there. So what needs to be done is to multiply. So let's get rid of the brackets, let's multiply. So if I multiply to get rid of the brackets, half times x sine 2x over 2 is x sine 2x divided by, and 2 into 2 gives me 4. Half times cos 2x over 4 is plus cos 2x divided by 2 into 4 being 8. And half times x squared over 2 is plus x squared over 2 into 2, which is 4, plus c. So this should be the solution to part B. So that solves part B, and that also completes the solution to the whole question. So I hope you found this video helpful. I hope you enjoyed the video. If you did enjoy the video, a like rating is very much appreciated. Do plenty of practice exercises, and I hope to see you again. Thank you.